In this section of 6.2, we need to evaluate each expression by drawing a right triangle and labeling the sides. So for number 69, starting with my cosine, so I have a triangle that has one side that is, well, let's start with just a right triangle and call this angle theta. Then cosine of theta, whatever theta is, will be negative 7 over 25. So now we remember my SOHCAHTOA. So CAHTOA tells me that the cosine of theta is the adjacent over the hypotenuse. So that means this adjacent angle is the 7 and the 25 is the hypotenuse. So it must be that the 7 is negative to get that negative 7 over 25. So I'd actually have that triangle oriented in angle quadrant 3 or 4. I'm sorry, 2 or 3, so that I get the negative x. So it'd be more like this. Actually, I was positive because the output of inverse cosine is going to be that top half of the unit circle. So I know y will be positive. All right, and then the next task is to find y so that I can find sine. So I have a picture here that gives me, I can't really define the angle. I don't know the degree or the radian of the angle, but I can have it defined as a ratio of the cosine of negative 7 over 25. If I find that third side, which I get 24, because I had a Pythagorean triple, so to get that I would have gone y squared plus x squared equals the r squared, and r squared is 25 squared. X is negative 7 squared, and y squared. So y equals the square root of 25 squared minus 49, or negative 7 squared. Sorry, that's sloppy. Negative 7 squared, which gives me 24. Okay, so now that I have that third side, now I can take sine of that angle. So this inside part, I'm going to rewrite this actually. I'm going to rewrite this down here. So we're looking for sine of cosine inverse of negative 7 over 25. And again, I can't tell you what the angle is, but I can say that that angle, oops, sorry, I meant to have a highlighter there. This angle that I've defined with my triangle diagram is this value. So I could put that in the calculator and find out the actual angle, but that's not really necessary because I just want to find the sine of that angle. And I have a picture of it. And sine is opposite over hypotenuse. And I'm looking at my triangle, and I find that sine of that angle equals opposite, which is the 24, over the hypotenuse, which is 25. And again, it's positive since our inside value, that cosine inverse, is only defined on the top half of the unit circle. So there's my final answer. This equals that.